Greetings, globeheads and flurfers. I'm going to talk about a topic tonight that I have mentioned before, but it's important that I mention it now because you're a week away from a great opportunity. Listen up, flurfers. You have the opportunity to prove me wrong in 1 week. See, we are a week away from the equinox. We refer to it as the first day of fall or autumn in the northern hemisphere. For you Aussies, I guess it's the first day of spring. But either way, the equinox is an important day because on this day, something interesting happens as far as how the light comes in to the earth from the sun. Now, you can prove me wrong or prove this right yourself next week, September 23rd, September 22nd, right around there. Right around there. You will find if you go out in the morning with your compass and you shoot an azimuth, that's measure with your compass exactly where the sun comes up, you will find that it'll come up at 90 degrees. That's due east. Now, there's one caveat to that. You need to understand the magnetic North Pole is not exactly in the same spot as true north. The North Pole where the Earth spins on its axis, yes it does, whether you deny it or not, is not the exact place where the magnetic North Pole is. The magnetic North Pole is way up there inside the Arctic Circle. I think it's actually in Canada's territory, I'm not sure. But it's not in the exact same spot. And because of that, when you shoot an azimuth with a compass, you have to adjust for what we call declination, the difference between magnetic north and true north. And you can look that up on the internet or anywhere. If you have a military map of your area, it'll show you the declination. Anybody who any of you who have ever been in the military will know this and have experience using this in land navigation, that you have to adjust from magnetic north to true north. But you have to first find out what the declination is in your area and either add or subtract based on where you are to get true north and the other cardinal directions. It's usually just a couple of degrees if you're pretty far south. If you're way up north, the closer you get to, true North Pole, the more wildly off that magnetic north is going to be. But typically in the United States, it's a couple degrees, especially down south. So find out what that is. Go out, shoot your azimuth, adjust for that declination, and you will find out that the sun rises on the equinox at due east, 90 degrees. Then go in the evening and watch the sunset, and again, shoot an azimuth of it, and you will find that the sun sets at 270 degrees. Now, there's a couple of things interesting about this. One, if you had a flat disk with the sun going around in a circle above this flat disk with the North Pole, the center of that circle, as many flurfers tend to believe, then where you saw the sun come up as far as angles on the compass would depend a lot on where you are, right? But on the equinox, that sun will come up 90 degrees everywhere. It'll come up at 90 degrees in Sydney, Australia, and it'll come up at 90 degrees in North America, and it will come up at 90 degrees on the equator. And it will set at 270 degrees due west everywhere. That only works on a globe. But more importantly, it couldn't pretty much anywhere do that on a disk. Think about this. You're on a disk. You see the sun for 12 hours, which is exactly how long it'll be up on the equinox. 12 hours, we'll have 12 hours of sunlight. It's actually maybe 12 hours and 1 minute or something like that. And that's just because the sun has, some angular width. And so the sunrise and the sunset, you have to add in the width of the sun. And so it's 12 hours and a minute or two. But basically 12 hours. Think about this. If it's going around in a circle in 24 hours and you are seeing it for 12 hours, then you are able to witness half of that circle. Now, if that circle is coming around from the northeast, swinging around to the south of you from where I live in the northern hemisphere, and then heading off to the northwest, then it's impossible for you to see it rise. It has to rise somewhere north of east and set somewhere north of west. Geometry requires that. But furthermore, if you happen to be on the equator during the equinox, it doesn't even appear to pass to the south of you. The sun will rise due east, pass directly overhead, set due west, therefore making a perfectly straight line across the sky in 12 hours. Now explain to me how anything traveling in a circle in a 24-hour period can travel in a straight line in 12 hours, for 12 hours of that 24. If you think that's possible, you don't even know what a circle is. Again, you don't have to believe anything I say. Just step out there with your compass next week and test it out for yourself.